Hello, today I'm going to be talking about dynamics. I'm specifically going to talk about Newton's first law of motion, free body diagrams, and Newton's second law of motion, and then I will be applying these to an AP multiple choice section problem. So first, I'm going to talk about Newton's first law of motion, which states that an object at rest will remain at rest. An object in motion will remain in motion at a constant velocity and in a straight line, unless acted upon by a net force. So it's important to note that Newton's first law of motion can also be referred to as the law of inertia. So I'm going to go ahead and define some terms before we move on to free body diagram. So an object's inertia is defined as the tendency of an object to resist a change in velocity. The inertial mass is a measure of an object's inertia and is oftentimes referred to just as mass. A force is a vector quantity describing the push or the pull on an object. And the net force is defined as the vector sum of all the forces acting on an object. Okay, so now I'm going to move on to free body diagrams. So a free body diagram is essentially a representation of an object or system with vector arrows that show all the external forces acting on the object. A free body diagram is essential when looking at a system to solve all forces and find the net force of the system. So now I'm going to go ahead and talk about Newton's second law of motion. Newton's second law of motion states that a net force applied to an object changes an object's velocity. And it is frequently written as the sum of forces is equal to the net force, which is equal to the mass times the acceleration, which is also equal to the derivative of velocity. So this is a kinematic property that acceleration is equal to the derivative of velocity. So Newton's second law of motion can also be written as acceleration is equal to the net force divided by the mass, or again, the property of inertia. So that's a little bit of an overview on the three. So now I'm going to go ahead and apply this to a problem. So we're going to be looking at problem number 20. I'm going to go ahead and read the problem out loud. So a student throws a metal sphere, which follows the path shown above. If air resistance is negligible, which of the following is a correct relationship between the magnitudes of the accelerations AK, AL, and AM at the 3 points shown? So I'm going to go ahead and draw the diagram. We've got our floor here. This is the path of the metal sphere, which represents a projectile motion. So we've got the sphere here at point K, here at point L, and then again at point M. And the force that acts on the net force of each one, we can look at the equation acceleration times mass. So here the only force acting on each point of the sphere is gravitational force. So we know that acceleration is just going to be equal to g. So we can say that the net force is equal to mg, which on the graph should look something like this: mg and mg. So we know that the acceleration of k is equal to mg. Oh, wait, sorry. What is the relationship between the 3 points? Right. So essentially, we don't even have to look at anything else. We know that the acceleration of k is going to be equal to the acceleration of L, which is equal to the acceleration of m, because all the net forces are equal to one another. And the acceleration for all three of them is just the gravitational force, which is G. So we can conclude that acceleration K is going to be equal to acceleration L, which is equal to acceleration M. And this translates over to option A on the multiple choice exam. Thank you.